Hi guys. All right, so in the last video, I said we could do a whole problem without doing any work whatsoever. And while that is sometimes true, there are some problems where you are going to have to do a little bit of calculation. Specifically, if your x-intercepts or your y-intercepts don't work out nicely, then you might need to do a little bit of calculating. So we're actually going to hit both of those scenarios in this next example. So we're going to have crazy x-intercepts. We're going to have a y-intercept that we can't see on the graph, so we'll need to calculate it. Now, this doesn't happen all the time, but I did want to make sure that I went over with you when you do need to do some calculations. But that's not till like the very, very end. So we're going to start with like super easy, stare at it, write some answers, no work required. We are still working on that worksheet. So, I gave you 2 spaces, so you can write this one in the second space. And let's start with our axis of symmetry. So our axis of symmetry, remember, if it helps, you can write down the parentheses and set it equal to 0. And then you would solve for x, and that'll be your axis of symmetry. Okay, so x equals -3. For my vertex, I have my -3 already, and then I'm going to take that +5 from the end to be my y coordinate, so -3, 5. In this problem, my A is -2, so this parabola will be opening down with a maximum point. My domain is all real numbers, and my range, since it's opening down, is less than or equal to the number 5 from the vertex. Okay, so look at that. So many answers, and we did it like, I don't even know. I should time myself, like so fast, right? Again, on vertex form, you can't do the intercepts until after you've graphed. So I'm going to skip the intercepts and go to the graphing part next. So I have my axis of symmetry is at the -3. And then my vertex is at the -3, +5. My special ordered pairs will change a little bit this time because my A is -2. So instead of 1, 1, I'm going to go 1, -2. So from my vertex, I go right 1 and down to 2, and I reflect. My next special ordered pair will change to 2, -8. So again, from my vertex, I'm going to go right 2 and down 8, and reflect. And I don't think I can fit the next one, so I did not write down the next one. It would be 3, -18, but that's going to be off of the graph. So I'm going to go ahead and draw my parabola right now. Now, the only things that we have not answered yet are the intercepts. But this one is going to get a little bit weird. So let's talk about our intercepts. I'm going to start with the x-intercepts. Those are a little bit more difficult, and then we'll do the y-intercept. Okay, so x-intercepts, if you remember, are written as an ordered pair, a number, 0. And in this problem, my x-intercepts are not on nice whole numbers. So when I look at my graph, it's crossing somewhere between the -1 and the -2, and somewhere between the -4 and the -5. And so since it's crossing between 2 numbers, I will need to calculate my x-intercepts. On standard form, we could use quadratic formula because we had an A, B, and C, but we don't have an A, B, and C for vertex form. So what we'll have to do is we'll have to plug in a 0 for the letter y, and we'll need to solve. This is going to look kind of similar to when we were solving by completing the square before winter break. So right now, what I'm going to do, I'm going to try to get my parentheses all by itself. And so I'm going to move the stuff that's not in the parentheses, the stuff that's outside. We always start by moving, adding, and subtracting. So I'm going to start by moving the +5 to the other side by subtracting it. And then next, I'm going to move this -2, which is being multiplied with my parentheses. So when I move it, I'm going to divide by the -2. Now that my parentheses is all by itself, I can get rid of the parentheses by square rooting both sides. We learned this last chapter, right? We do a square root here. We do a square root here. These cancel. And on this side, we put a plus or minus, right? So, and that's where, again, we're going to get weird answers because it wasn't crossing on a whole number. Our last step to get the letter x by itself, we're going to subtract the 3 to the other side. And I like to put that in front of the plus or minus sign because I think that's the least confusing place to put it. So it's -3 plus or minus. And go ahead and just leave this a crazy fraction. I'm fine with that. So crazy fraction is okay. Square root of 5/2 or 2.5 if you want to change it to a decimal. And that's my x-intercepts. So crazy, crazy answers when it does not cross on a nice whole number. That won't happen all the time, but it does happen. So I wanted to make sure that we went over it in the video. It will happen once on tonight's homework. All right, so those are the x-intercepts. But now we need to talk about the y-intercept. A parabola will always have one y-intercept. Always. Every parabola has a y-intercept. In this problem, my y-intercept is just a little bit too far down, a little bit off the graph. If I had actually done my next special ordered pair, I would have hit the y-axis, but I ran out of space. So if your y-intercept is not visible on the graph that you graphed, that doesn't mean it doesn't exist. That just means that it's off the graph, and we can find it using calculations. So for a y-intercept, we do the opposite of an x-intercept. We put a 0 for the x. So I'm going to plug in a 0 for this x. And don't worry, this one is so much easier than the x-intercept. You could actually, if you wanted to, just type that into your calculator exactly how it looks. And then that'll be your answer. Or I'm going to do it by hand, right? Because the number is not too crazy. So just make sure that you're doing the order of operations, which says I need to add the 0 and the 3 first. Then I need to square the 3. Then I'll multiply the -2 and the 9. And then finally, I'll add those numbers together. And so my y-intercept is at 0, -13. And again, we would have gotten there if we had gone over 3 and down 18, we would have gotten to the -13. It was just a little bit too far off the graph for me to see it when I was creating the parabola, but it does exist. All right, so just be on the lookout for these two scenarios where you might have to do some calculations. And so the homework won't be completely calculation free. You will need to calculate once. You'll have to calculate the x-intercepts, and then you might need to calculate the y-intercept as well. That one's a little bit easier. This concludes our notes for today.